Good day, everyone. Today, I am going to discuss each of the problem set given in application of derivatives of functions. Given problem number 1, consider the graph y equals s of t representing the position in kilometers of a delivery truck from a warehouse. Time t is measured in hours after 8 a.m. So since the graph y equals s of t is mentioned, but the graph itself is not shown in the image, so exact values cannot be determined. So, to answer the first question, when is the truck closest to the warehouse? So, the truck is closest when the position function s of t has its smallest value. So since the graph is not given, so I have just conceptually answered it, in which the truck is closest to the warehouse when S of t is smallest, or when S of t is at its minimum value. So the second question, describe the motion of the truck from 8 a.m. to 2 p.m. To answer, if S of t increases, the truck moves away from the warehouse. If S of t decreases, the truck moves toward the warehouse, and if S of t is constant, the truck is stopped. So that is the flow of the motion of the truck from 8 a.m. to 2 p.m. And this exactly reflects about the minimum and the maximum value. So to answer C rather, or letter C rather, when S prime of t equals 0, and what does this indicate about the truck's motion? So S prime of t equals 0 when the graph of S of t has a horizontal tangent. And this means the track is temporarily stopped, or it changes direction. So that is the answer when the S prime of t equals 0, and its indication about the track's motion. It means that the track is temporarily stopped, or it has changes its direction. So that is our answer for letter C. Now to answer letter D, what does S prime of t represent? And what is S double prime t represent as well? So that we know that when we say about a position and then finding its first derivative, so it talks about the velocity. So therefore, the S prime of t, which is the derivative of the position, talks about or represents the velocity of the track. And when it's positive, it means that it moves away from the warehouse. And when it is negative, it moves away from the warehouse. And when it's zero, it's stopped. And the unit it should use is the kilometer per meter. So now moving to the meaning of the S double prime t, it basically represents the acceleration, since the derivative of the velocity itself is the acceleration. And if it's positive, meaning velocity is increasing, and negative, if the acceleration is negative, then the velocity is decreasing. And the units to use, since we are talking about acceleration, is kilometer per meter squared. And another answer for this is that, or to answer this in short, S prime of t is the velocity of the track. It means the rate of change of the position. And when we say about S double prime t, it means acceleration of the track again, and it talks about the rate of change of velocity. So from here, it's about the change in position, and here it's about the change in velocity. Moving on to our question number 2. A cup of coffee rather is placed on a table in a room with a constant temperature of 25 degrees Celsius. Let T of T be the temperature of the coffee in degrees Celsius after T minutes. So the question number 1 goes like this. So let us consider the variables there, in which the room temperature is 25 degrees Celsius and the T of T is temperature after T minutes. That is why it is represented by T of t. So question number 1 goes like this. What does T of 10 equals 60 mean? So basically, we know that the t represented here is about the minutes from the question there after t minutes. So therefore, t represents the number of minutes. And since it is substituted by 10, therefore, this means that after 10 minutes, the coffee temperature is 60 degrees Celsius. So therefore, the little t is represented by 10 minutes, and so the coffee temperature is 60 degrees Celsius. Moving on to letter B question. Suppose t prime of 10 equals negative 1.5. What are the units of t prime of t? And what does this value mean? So units of t prime of t. Since temperature is in degrees Celsius, time is in minutes, the units therefore are degrees Celsius per minute. And of course, this means that after 10 minutes, the coffee temperature is decreasing at a rate of 1.5 degrees Celsius per minute. So since it talks about negative sign, therefore, the coffee is decreasing in its temperature and thus it is cooling. And that is the answer for letter B. Now to proceed, question C goes like this. Estimate T of 12. So by estimating this, we are going to use the linear approximation in which t of 12 will be approximately equal to t of 10 plus t prime 10 times 12 minus 2. Since when we say linear approximation, it's about the distance. And in this case, we are going to um, include that or involve the 12 and 10 from here. So the estimated change is the delta t is approximately t prime of 10 times 2. And since given that t prime of 10 equals negative 1.5 from letter C, from letter C, yes, from letter B rather, from earlier problem in which it was 1.5 here. So by using the linear approximation, we have obtained 57 degrees Celsius. Since our T of 10 is 60 and T prime of 10 is negative 1.5, and by using the linear approximation, we have just subtracted 12 by 10, and thus the answer is 2. And by calculating it, we are going to multiply the T prime of 10 times 2. And since T prime of 10 is negative 1.5 from here given, and multiplied by 2 as the difference of this 2 here. So the answer for that is negative 3. So T of 12 can be obtained through subtracting 3 from 60. So 60 minus 3 is 57 degrees Celsius. So that is the estimation for T of 12, or T given in 12 minutes. Therefore, this means that after 12 minutes, the coffee temperature is 57 degrees Celsius. It means that it is decreasing since from T of 10 is 60 and now T of 12 is 57 degrees Celsius. Therefore, it decreases. Number 3 question. A ball is shown straight upward from the ground with an initial velocity of 64 feet per second. Its height after t seconds is given by s of t equals negative 16t squared plus 64t. The first question goes like this. Find velocity and acceleration. So we know that the velocity is the derivative of the position. So therefore we can have this formula. V of t is just the same as s prime of t. So therefore s prime of t equals d over derivative of t, and that is equal to negative 16t squared plus 64t. And then by applying the rule, we are just going to multiply the power to the coefficient, which is negative 16, and 2 times negative 16 is negative 32. And then we are going to subtract the power by 1. Thus 2 minus 1 is just 1, and we haven't included it on its power since 1 can be determined as t. And then the derivative of 64t is simply 64, since we have 1 as its power. 1 times 64 is just 64. And then the power 1, which will be subtracted by 1, is just 0. So therefore, the t is gone there. And therefore, we are remained with the answer negative 32t plus 64 as the velocity of the given function. Now, so this is just a matter of differentiation by using the rule that is appropriate for the given function. Moving on to the acceleration. So since earlier the answer for the velocity is negative 32t plus 64, now we are going to find its derivative, in which is the acceleration. So a of t, which represented by acceleration, equals v prime of t, which is the derivative of the velocity. And since we are given the equation earlier, negative 32 t plus 64, and as you can see, 64 is gone since the derivative of a constant is 0. And then we will just simply multiply the power of t, which is represented by 1, multiply to negative 32, which is just negative 32, and the power of t, which is 1, subtracted by 1, is just 0. So therefore, we are having negative 32 as our acceleration answer. So therefore, our answer for the velocity is simply negative 32 t plus 64, and then our, wait, acceleration is negative 32. Moving on to letter B, when does the ball reach its maximum height? So we will be calculating its maxima, or the maximum point. So maximum height occurs when velocity is 0. So let us set the differentiated position into 0. So earlier we have obtained it as negative 32 plus negative 32t rather plus 64, and then set it to 0. And now we have just moved 64 on the other side, and then we divided each side by negative 32, and by applying division, we have obtained the answer, which is 2 seconds. So after 2 seconds, the ball will reach its maximum height in just 2 seconds. So for moving on to question C, what is the maximum height reached? So all we just need to do is we are going to substitute 2 on the given function, which is negative 16 and then substituted by 2 squared plus 64 substituted by 2. And so, by applying operations, 2 to the power of 2, that is 4, and then 64 times 2, that's 128. So for 14 times negative 16, that's negative 64 plus 128. The answer is 64. So therefore, the maximum height reached is at 64 feet. So this is just simply substituting 2 seconds or the number 2 to the given function. Literally, the application of velocity and acceleration along with the minimum and the maximum point. Letter D is when does the ball hit the ground? So all we just need to do is to set the given function into 0. S of t equals negative 16t squared plus 64t equals 0. And then all we just need to do is to factor out this given function, and the factor that we have obtained from both two terms is negative 16t. And then negative 16t squared divided by negative 16t, that is t, and then 64t divided by negative 16t, that gives us 4. So since t equals 0 is the launch time, therefore the answer is at 4 seconds. So therefore the answer for this, or the interpretation for this one, is that the ball hits the ground after 4 seconds, or it takes the ball to reach the ground in just 4 seconds. Now moving on, number 4. So the problem number 4 is given. A company manufactures headphones and the cost function is given by C of x equals 0.02x squared plus 30x plus 500. So now we are going to find the average cost per unit. So all we just need to do to find the average cost per unit is to just simply the divide this given function by x. So 0.02x squared divided by x is simply 0.02x, and then 30x divided by x is 30, and then 500 divided by x is just 500x. So each term was divided by x as its average. So question letter B is to find the marginal cost C prime of x. So to find the marginal cost is to just simply differentiate the cost function. So since our given function, there's 2 here, 2 there, our given function 0.02x squared plus 30x plus 500. So from this, 2 times 0.2 is just 0.04, and then 2 minus 1, that is 1, so therefore we are remained with 0.04x, and then the derivative of 30x is simply 30. Therefore, our marginal cost is given C prime of x equals 0.04x plus 30. I am sorry that I forgot to put 2 as the power of x here, but this is the original function given. Now for letter C, compute the average and marginal cost when x is equal to 500. So now to find the average cost, of course, we are going to use this this function 0.02x plus 30 plus 500 over x, and then substitute 500 into it. So now to substitute 500, it became 0.02 times 500 plus 30 plus 500 all over 500. So now to multiply 500 by 0.02, it gives us 10, and then copy 30 since it will not be multiplied by 500, and then plus 500 all over 500 since from this equation here. So now to apply operations, we are given or we have obtained t 10 rather plus 30 plus 1. So to add all together, we obtain 41 per unit. So therefore, our average cost is 41 per unit by using the average cost function. And then to find the marginal cost, of course, we are going to use the differentiated function, which is 0.04x plus 30. So marginal cost is c prime of x equals 0.04, and then substitute 500 into x plus 30. So 0.04 times 500 is 20 plus 30 there, that's 30. So 20 plus 30 is 50. So therefore, our marginal cost is 50. Letter D, interpret the meaning of marginal cost at x equals 500. So c prime 500 equals 50 based on this function, marginal cost function. So this means that when example 500 headphones are being produced, the cost of producing one additional headphone is now 50 pesos. So that is how marginal cost works. Moving on to our number 5. The population of a small town is modeled by P of t equals 2000 plus 150t, where t is measured in years. So first question, what does P of t represent? Or P of 5 rather, it's not t. What does P of 5 represent? So since from the given problem where t is measured in years. Therefore, it is very understandable that P of 5 represents the population after 5 years. So let us try to compute after 5 years. So we will just substitute 5 upon the given function. So that is P of 5 equals 2000 plus 150 times 5. So that would be 2000 plus 750, and then 2000 plus 750, that is 2750. And this means that town population after 5 years is 2,750 people. So moving forward to letter B, find P prime of t and interpret. So P of t is 2000 plus 150t, and to derive P prime of t, that would be 50, since derivative of 2000 is 0, and then derivative of 150t is simply 150. And this means that the population increases by 150 per year. Now P of t, it represents the population and how it increases after a year. And since we have obtained 150, therefore, the number of people gets to be increased by 150 per year. Number C question, is the population increasing or decreasing? So since it is understandable that 150 is greater than 0, therefore the population is increasing. Moving on to letter D, what does the constant rate of change tell you about the model? So to answer, the model assumes linear growth of 150 people per year. That's simply as that. Number 6. This is about cyclist motion. The distance traveled by a cyclist is given by S of t equals t cubed minus 6t squared plus 90, where t is in hours and S of t is in kilometers. Question A. Find the velocity and acceleration functions. So the velocity here, it can be obtained by differentiating the position, which is t cubed minus 6t squared plus 90. And then to differentiate it, all we just need to do is to get the derivative of each term. Derivative of t cubed is simply 3t squared. Derivative of negative 6t squared is negative 12t, and derivative of 90, that's 9. Therefore, our velocity from the given function is 3t squared minus 12t plus 9. And for our acceleration, of course, we will just differentiate the velocity here, which now becomes s double prime of t, and derivative of 3t squared here is 6t, and derivative of negative 12t is negative 12. Therefore, our acceleration is 6t minus 12. Hope is it hope that all of the answers were very, very clear to you. Letter B, when is the cyclist at rest? So we can set this into 0, the velocity at 0. So therefore, we are going to factor this one here, and we have obtained 3 times the quantity of t minus 1 and times the quantity of t minus 3 equals 0. So, transposing all this, negative 1 and negative 3 on each side, therefore t is equal to 1 and 3. So, to interpret this one, at t equals 1 hour, the cyclist stops moving for an instant, and at 3 equals 3 hours, the cyclist stops moving again. Therefore, after 1 hour, the cyclist stops from moving, and then after 3 hours of moving, the cyclist stops moving again. That is how it works. Now for letter C, when is the cyclist speeding up? So to know when the cyclist speeding up rather, we are going to find or test signs from the given velocity. So we are given here t is greater than 0 but lesser than 1. So let us try to find any number that we can define here. So we can try 0 0.1, 0 0.2, and 0 0.3 and try to plug them in here. So let's try 0 0.1. So 0 0.1 minus 1, that is negative 0 0.9. So that is negative here. And then 0 0.1 minus 3, that is negative 2.9. So negative times negative, that's positive. And then let's try to find a number that can be used here. So t is greater than t but lesser than 3. T is greater than 1 but lesser than 3 rather. So let's try to plug in 2. So t minus 1, t minus 2, that is, or 2 minus 1, sorry, 2 minus 1, that is 1. And then 2 minus 3, that is negative 1. So negative times positive here, that's negative. So let's try to plug in a number that is greater than 3. Let's try 4. So 4 minus 1, that is 3, which is positive. And then 4 minus 3, that's 1, which is positive. Now, positive times positive, that is positive. Now let us try to test the signs for acceleration. Here given a of t equals 6 times t minus 2. So we have just factored the function for the acceleration. So when t is lesser than 2, let's try 1, that's negative. And when t is greater than 2, let's try 3, that's positive. So now let us going to determine the signs that are the same or matches from velocity and acceleration. So since we can find this one here and this one here as negative signs, therefore we can combine them all together, which is 1, t is greater than 1 but is less than 2. That's both negative, which means that the cyclist is speeding up. And then since from here it's both positive, and then let's consider t is greater than 3, which is positive, and which means the cyclist is speeding up. Therefore, since all these signs matches all together from velocity and acceleration, therefore our answer is 1 and 2 and 3 positive infinity. since this means that this includes numbers that are greater than 3. Therefore, 3 is included and then 8 is included as well. And then the 1 and 2 here also is included. Therefore, the cyclist speeds up from 1 to 2 hours and again after 3 hours. Now moving on, now let us going to answer the last question, which is letter D. Describe the motion of cyclist from t equals 0 to t equals 4. So from the given earlier, we know that from 0 or from t is greater than 0 but less than 1, the velocity is positive, so the cyclist moves forward. And at t equals 1, the cyclist stops, since this is constant. From t is greater than 1 but lesser than 3, the velocity is negative, so the cyclist moves backward. So we know this already from the previous one, and then since the velocity is negative, that means that it moves backward. And at t equals 3, the cyclist stops again. So therefore, from t is greater than 3 but lesser than 4, the velocity is positive. So the cyclist moves forward again. So we can use always the given here or the factored one here from velocity in order for us to know if it is positive or negative. We will just simply look for a number that can be used knowing this fact, and then let's try to substitute it here and then find whether it is positive or negative. But since it is positive, so the cyclist moves forward again. Therefore, the cyclist moves forward, stops at t equals 1, moves forward again, and stops at t equals 3, then moves forward again. And we also have a question earlier from letter B. When is the cyclist at rest? So it stops at 1 and 3. This is the basis why at 1 and 3 the cyclist is at rest. And that would be all for the application of derivatives. And that includes the velocity and acceleration. And I have just learned that the derivative of position is velocity and the derivative of velocity is the acceleration, and that is how it is applied in daily life, which is very, very important in order for the people to calculate such things and for them to meaningfully manipulate these things in order for them to fully realize how mathematics applied in daily life. That would be all. Thank you.